I'm Maxime Veron from the Université Pierre Curie, France. I'm here and I will be your host for the next 18 minutes, and I'll be glad to be it. I'm going to introduce to the work we did for Nasdaq 14, the matchmaking in multiple online games, how to study the traces to improve the user experience. So, the basic idea was we had to study some game traces to be able to analyze the gaming industry and the gaming protocols and designs behind some big gaming architectures. But the problem is that we found few data sets that are really related deeply into precise detail of the gaming. We found some that are about positions of avatar in games that are really useful for some people who do some specialization, localization, and sharding into universes. We found some information also for being relative in first-person shooter games. But we didn't find something enough for our target, which was the matchmaking systems. Matchmaking systems relate into making two players, or two users, into relation automatically according to multiple preferences or choice that they can set up, or that are automatically set up by the game. Some preferences might be the language, but something automatically set up might be the level of the player that cannot be modulated by hand. So we had to improve those future gaming solutions. And we had to do it by ourselves. So we had to first of all choose a popular game. That seems pretty obvious. If we want to work with the future gaming solutions, we have to find the current ones that are working, then gather information, and then assess its matchmaking. So that the colors, that's one video. So we chose League of Legends as our target application for multiple points and multiple reasons. First of all, nowadays, League of Legends has one of the biggest and largest player base. Also, it allows to have free data from players, and finally, integrate the matchmaking systems. So, what I mean by allowing to access free data about players is that there is a huge number of data you can access about players publicly from the servers. There is a lot of information that is here waiting to be taken from by people, and we had to do it to analyze the matchmaking system. So the process we went through is that we first of all extracted this raw data from the servers to then after give a meaning to this data. What I mean by the data meaning is like associate every raw value to something meaningful for the game. So from this we got the database schema that we created on the database that we publicly available after. And from this database schema we can then after crawl over months. We got the amount of information we crawled, and this amount of information got around more than 2 million unique users that played over these months. And in every type of possible session in the game. This is an important point because in League of Legends you have multiple types of choice of little games you can make, and this is also a matter of like, if you want to make some analysis, you can analyze different behaviors in different type of sessions. So you can really fully analyze all components of a game and of a free-to-play game. So from these fair deductions we can make, then you have the analysis that comes into the part where we extract the important fields for the matchmaking, because we were going to analyze it, and then, for example, see the impact of ping that player can have to the server, the ranking distance between players, and so on. So we classified the data we retrieved into three major parts. First of all, the one that was interesting for our analysis, the matchmaking fields. Like for example, there is publicly available how much time the player waited in the queue for matchmaking. So how much time he was waiting in milliseconds. Pretty good information for us. Then the type of queue was waiting for. Also want to know if he's going to fight against a player with the same ranking as him, or if he's just fighting versus the computer-controlled avatars. Also important, if he's with friends or not, waiting in the queue. You can group up with people and then go together in the same game. This is important if you want to, for example, analyze the impact of being grouped in a game compared to just single players. And finally, the rating of one player, how much he performed well normally in the game. Then we have the second category that we defined as company handlers. This is more if you want to analyze things such as the free-to-play model of gaming. Here, with the company handlers, you can see some fields that are really necessary for the company to maintain the game. You can see which type of skin. The skin is something you can buy in the game for real money. So it's interesting to know, for example, when people in the game start to buy their first skin and play with it, or which one they play more, which one they buy more. This is typically information about related what provides you money in your game, or which content was giving you back money, what content player bought for you. Also, you can have information about the IP earned. The IP earned is the current money you gain in game, the one that you don't pay for it. Also here you can get the information about how much this fake currencies earned by players. Is it really fair? You could analyze, for example, is this game possible to unlock everything with just playing normally? And you can see how much you need to play to actually unlock everything in this free game. Then also you have one more thing like the boost IP and then ID field, identifiers. So this is really company stuff related. And finally, the avatar information is that we call information is information related to what could be one player or one typical player in every other type of game. Here you have items. In every game you find items, like role-playing game you have items, first-person shooters you have items, you have different types of guns. So this could apply for any type of game. You could make some comparisons with other type of games. As long as it's an avatar, of course. Then you have spells, or this is more likely to be close to role-playing games. But then you have the number of deaths, that is applicable to any possible type of game. You have the money you earn in the game, etc. So later on I'm going to show you a little bit more about these fields. I insist a bit on it because the database is freely available online, so you can really have to if you want to work on it. So now to the analysis that we had from this, we first of all designed something really simple, which is the distribution of ping of gamers. Here from the database, we directly got a distribution, and what we can observe first of all is that players nowadays are really well connected. You see that the peak of the curve is around under 50 millisecond ping, which is pretty low from what you could have expected. A couple of years ago, I would have expected something more around 60 to nearly 100 ping. So nowadays, if a company wants to build a game, you can now consider that players will mostly have low ping, which makes for them that they can make more precise events and more detailed applications, because they will have the reliability that the players will have a good connection. So that's one major point. And also, we decided that, okay, we have the ping now. We're going to try to see, can we go from this ping to performance of one player? So, we are going to introduce here what is called in the game the KDA, the Keyless Assist Ratio. It's a value you can compute to see one player performance in one game. And really, it's strictly individual. So it's simple. You make the sum of the number of avatars you killed, the number you helped to kill, and you divide by the maximum of deaths and more. So this value reflects if you perform well, because if you manage to help or kill other avatars without dying, you're probably working pretty good there. And the opposite, of course, if your KDA is pretty low or below 1, you're going pretty bad. This value, though, cannot measure team efforts. That's, of course, true, but anyway, in our database, each session value is logged for the point of view of the user. So anyway, you will have the information about the user and not the team of the user. You have some information about the team, such as the rating level of the team, but you don't have the information about the team. So coming from this thing to go to performance, we graphed a couple of things, and we are going to introduce some more concepts here. Here you have all what is called the leagues, which is different classification of player. It comes from the lowest ranked player to the highest ranked player. We type by basically how much in average ping a player corresponding to their ranking. So you can see that the lowest tier of player actually does have also the highest average ping in the game, and it goes down until the highest ranked player. Then also we graphed on the database that we made finally this KDA ratio according to ping, and we can see that in the lowest ping the KDA is efficiently the highest value. And in the end, we wanted to see also what was the reproduction of this KDA regarding to the leagues. But we saw that the KDA is not moving much from leagues. So what we could understand from these three graphs is multiple conclusions. One strong that we are sure about is that the ping really do impede on performance. You can see there is a relation about ranking and low ping and KDA regarding to ping. But also, you could maybe think that players who have better connection are better players. Here, they are all related here, on average. But you see that the KDA is not that high. Which means behind this is that actually it's not likely that players who have better connection will tend to be better players. It's also that the motive that players who have better ranking and better skills tend to invest money into better connection. And then you have the both effects coming into these two graphs that makes that also players who have a high ranking then will buy, and players who have better ping will tend to be slightly better, according to the graph in the middle. So surely in this type of game, the mobile multiplayer online battle arenas, it's more likely to be close to first-person shooters. Some people may have said that those type of games are closer to strategy games, where economy is more important than precise action. Here it shows clearly that this type of games is closer to FPS in a way that the ping really impedes on performance. If you go from 100 milliseconds already, you lost a huge amount of KDA possible. So you're really losing part of your chances to get better with this. And this can be explained by a simple way, is that in those kind of games, you have, like in those type of games, some small time frames where the 3D models will do some actions that are called wind-up animations. And these animations, in case of high ping, will be cut off. This is the way to avoid the user to have an impression of bad gameplay, of deteriorated gameplay. These animations are just normally visual and supposed to make the game smoother. But if you have high ping, they will be cut off. You will not feel it. Some highly ranked player can feel it, and then cannot anticipate as well if there's high ping. Finally, we're going to go to the matchmaking, again with the leagues. The leagues are separated roughly around 3,000 points of elo, the value used to compute in chess the ranking of one player. And here in this graphic, we plotted the difference in the distance of ranked player and the timing cube regarding also to the defection coefficient. The defection coefficient is the ratio we computed regarding the place we found the highest number of levers in game, and the value of 1 corresponds to the highest point, and the other value corresponds to the ratio compared to the biggest one. We found out that in League of Legends, there is 2 peaks of defections and of waiting time that are related to the distance that you have between players between one league. That means that mostly matchmaking systems of League of Legends will wait more before matching you against someone of another league, which is totally good, because then you see that if you pass this cap, you raise a defection coefficient. That means that at the point where the matchmaking said, okay, I cannot wait so long, I will not find a combination, I will take this combination, where you have a player from a different league, you are most likely going to find a player from another division that's going to lead in this match. So, faster in matchmaking is not always the better. That's one major point here. If you go faster, you will find that actually the players are going to leave the games, are going to not be happy about it. You're going to have to aim for a good match here, and not for a fast match. Another point we found is that the matchmaking here in League of Legends does not scale. So this point is pretty big. As you can see that here, in the point where there is the highest number of players, this is also where you have the highest waiting time. This shouldn't be like this. This is where the matchmaking has the most large amount of players to work with, and this is where it takes the longer time to reply. That clearly means that something is going wrong there. Also, to compensate, to accentuate this finding, is that where there is fewer players, we can also see that the matchmaking systems reply faster. Meaning that clearly, when the system is empty and without anybody waiting for it, it replies faster. But as soon as there is users entering the system, it doesn't reply on time anymore. Which here means that there is somewhere a potential design flow and scalability issue in the system. So as we were saying, we were studying the free-to-play. Now I'm going to turn to the free-to-study. If you want, a database is freely available on my website. It will be accessible, and you have the database code and also the crawling code if you want to crawl also for yourself. And you can contact me also if you want to work with me or for more information. The contact information is also on my webpage. There's everything you need there. And finally, you have the list of the complete kernel database. So this is kind of huge, but I just wanted to show here that you have plenty of fields to work on if you want. And this also helps, so you can see that there is a lot of different type of information from the game. And so in conclusion, we're going to give, first of all, this free available database full of gaming information that we found novel in the domain. And then also we showed in a way that calling public data from games should be systematic in a way that you can easily then after find some critical design flows where, for example, the matchmaking did not scale in this case and should be fixed. This is a high problem, and this is shown just by crawling for over months. Imagine if the company did itself, maybe you could have saw that there was a problem in the architecture. And so that's what we say, crawling the public information really helps identifying these design flows and will then in the future improve the gaming architectures. So I thank you all, and I'm waiting for the questions now. The database here is around 7 GB. I have a one that is getting crawling that is getting bigger, but yeah, this one still is remains notable from here. Now you mean, or this one? Oh, this one. I think we reached. Oops, sorry. I think we reached about like maybe more than 5-6 means, but it's because I had some trouble with the database architectures. So we have to stop and restart the database. Yeah. And we could, for example, if people wanted to work on a database, we could also work on the updated one with more information. That's obvious.
So, how would you suggest system designers when they're making matchmaking systems?
That's exactly a good question, because actually we're working on it actually right now, and we found actually some really simple ways to make it just better. Actually, we strongly believe that, first of all, we believe that we would like to decentralize the problem, because we were looking for centralized points. To run some quick simulation to show that actually, even on a single server, it could handle the anomaly. So there is something going wrong there, that in simple matchmaking, working like better with some better managing of lists of waiting could work better actually. The simple algorithm would work better. So just here apparently the algorithm must be pretty naive when implemented here.
So the problem you see is mainly a scalability problem that the server was overloaded with.
Here probably what's going to happen in this server, what we believe from the experiments we made after, is that probably they have a scalability issue in the list typically. You store players from different range of elo, and if the list, for example, is badly sized or not dynamically reallocated proportionally to the number of players inside, what you're going to find, you're going to have a huge list of players to match. You need to match 5 against 5. If you want to make 5 against 5 in the best possible combination in a huge list, you're going to saturate.
Have you tried using machine learning techniques to find possibly more parameters that are important, or is it wait in time?
So for the analysis, you mean?
Yes.
No, we didn't try to use machine learning. Maybe because also it's not really on the main field, but we could have used it definitely. But here the main point was really two contributions. Like one part is the database encoding, and the other part is small but efficient analysis. So we really could go higher on analysis, that's for sure.
Yes.
So yeah, there might be some work. That's why we invite people to of course work on it to change, because we strongly see that there is some work to do on it more.
I have a question about how you gather this log. Did you generate the summoner's ID random, or there is some list about the summoner's ID?
So what we did is like to do this. First of all, it was on two steps. First of all, was using the code that was available publicly online to access the game servers. That was the first step. Then we realized we can only access the history information by summoner ID, which is the ID inside, and this is the value corresponding to Riot games. But good for us, it starts from 0 and ends to the number of actual players in the game. So it's not totally randomly generated by Riot game. So what we could do is just call from 0 to the number of players. Simply as that. And to have maybe more accurate value, we took from this amount, we knew how much we could call over a month, we resized, then the random to have the uniform distribution in this number of players.
Okay, also a question, perhaps a final question. If you have other type of games like serious games, yeah, games for other purposes, where you also have multiplayer, may there be other parameters there to be more better, sweeter, better for finding the groups?
Parameters from other games, you mean?
Yes, for yeah.
So if I were to...
If you have other type of games, like serious games, where you want to do something else, like health or anything else,
okay.
What happens then?
If I have more parameters?
Yeah. Are there other parameters which would be better?
To matchmaking, you mean? Oh yeah, for sure. Sure. For example, of parameters that could add to matchmaking is, first of all, we saw that the thing impacts on performance would be fair to put people with the same thing, first of all. It was already suggested to add being as matchmaking constraints, but also simple things like if you have matchmaking that's here, you could add, for example, the language of people that they speak, so they can communicate together. And at other times, you could have, for example, a lot of parameters. For example, Riot Games try to add the number of games played per player. But what they saw is that it added in their matchmaking service, because of the constraint and the performance of the matchmaking service, that every player had to wait 1 minute more, flat, from 30 seconds past to 1 minute 30. Just by adding the number of games. So they couldn't add more constraints, but you see that there is a will to add more constraints in the matchmaking system. That's the question.
We can talk later.
Okay.
Okay,
Fine.
So I would like to introduce the next speaker. Thank you very much.